Hey everybody, it is April 13th and this is Chemistry for Faith Christian Academy, and we are in chapter 15, page 247, and as you can tell, this chapter 15 is over acids, bases, and salts. So that's one reason we got all this protective gear and all this good stuff. So let's just talk about some acids and bases. So as you can tell, they've got all these demonstrations that you're doing on page 247. I'm going to do that as well. We've got this weird thing. Remember way back a few chapters ago, we did this weird experiment where we took table sugar and we poured sulfuric acid on it, and it basically carbonized the sugar and made it almost look like a pumice stone or something like that from something volcanic. And today we're going to use some acid. I forgot my protective glove. It's just like so. So here we go. We've got some acid. And then we have a base. And then I've got some salt. The salt I'm not so worried about. The base I'm not really worried about. But the acid, yeah. What kind of acid could it be? All right, so I'm just going to introduce a little bit. I'm going to move this over here and get it away from me and take off this goggle, and then we'll do an experiment with it here in just a minute. Okay, so let's look at acids and bases. Of course, in chemistry, we've worked with these products quite a bit already, but almost everyone has some picture or idea what comes to mind when you say the word acid, base, salt. And of course, you've probably seen just in commercials, there's products that are, say, non-alkaline, or the big thing now is alkaline water, or pH, or acid balance, or low salt, or something that says it's going to neutralize stomach acid and things like that. Indeed, some of the most common compounds in our society are acids, bases, and salts. Lots of fruits, lots of foods contain acids. For example, my husband's favorite acid is citric acid, and if any of you all are Mountain Dew drinkers, it's because citric acid is in Mountain Dew, as well as there's other types of acids that we've used, like they're in apples, or that's in vinegar, or that's in grapes, or our own gastric juices is a hydrochloric acid. Vitamin C is an absorbic acid. Industry and agriculture uses sulfuric, phosphoric, nitric, hydrochloric. If you remember, sulfuric acid, the production of sulfuric acid was basically an indicator of the economics of the society. So we're going to just look at all of these household cleaning solutions like drain openers, antacids contain bases. Bases are also used in industrial processes. We've got salts. It's also used in home and industry. Now I'm going to go ahead and tell you that your chapter test will be only on chapter 15. It's a pretty big chapter and there's a lot of stuff to go over. So just as we go through this chapter, I'm going to tell you what the quiz notes are, tell you what the test notes are. I'm not sure when you're going to get that. We'll just have to see. It's more than likely it's not going to be this week. Maybe next week you'll get the chapter test on chapter 15. But I am sending home a quiz for this week on chapter 15. So we're just going to look at a few things here while we're just doing some demonstrations. So here's my acid. Yeah, look, I took off my glasses and stuff. And the reason why, we're going to try, you have a cute little thing given to you in your, hold on, I'm looking for books. See the demonstration they gave with litmus paper? We actually did this a while back. I'm trying to get where you've got litmus paper. That is still not showing up. Okay, so let's look at the litmus paper. This is an acid. So when I stick in that litmus paper, this blue should turn red. The red litmus paper should not change. So let's see if that works. So blue is going to turn red. So that's showing you it is an acid, right? Now I've got some red right here. So if I stick it in here in this acid, it should stay red. and it didn't change. You know, it got wet, but didn't change. So this is an acid. So that's one test for an acid. The other test, if you look right here, this is a test question. Oddly enough, this is a quiz question, a test question and a quiz question. And I'm going to sacrifice people so you can see, you know, what this is. The word acid comes from the Latin word acidus, and that Latin word means sour. And it's known that when you dissolve an acid in water, it has a sour taste. So, all right, here it goes, guys. It's definitely a sour taste. Now, you all can probably guess, I've used this acid quite a bit in your all science because it's really safe and you don't have to do much with it. Can you guess what this acid is? If you've ever eaten any type of pickle, you've had this acid. It's acetic acid, or it's white vinegar. Yeah. I mean, I like vinegar. I could drink it, but I'd prefer not to. I don't recommend it. Ugh. Now we also have a base. They've given you a base here as well. I'm going to tell you right off the bat, I'm not sure if this is going to work. Because the base I was wanting to get was milk. Could not find milk. And maybe it's because Miss Kim has cleaned up everything from the kitchen. We no longer have milk. But what I do have is something that's got some milk in it. And it's kind of turning it blue, but not so much. So a base should turn it blue, and this is not working, but this is really yummy. It's whipped cream. I was just trying to find something really quickly. I do not have oven cleaner or anything like that at school, so sorry. But you know, the blue strip did not change. And then this is, of course, is just your regular table salt that we've used quite a bit and stuff. So that's just an introduction. So what is both a quiz question and a test question on page 247? I would highlight the word acid and then everything that comes after it. So an acid, from the Latin word acidus, is known to have a sour taste when dissolved in water. So that is asked on a quiz. It's also asked on a test. So just make sure you know both of those. There are a few quizzes, I think a couple of quizzes on quiz 15. The first quiz that I'm sending to you next week is going to be over simply 15.1. So be prepared to go ahead and find that. So, of course, acids, we have dissolved zinc before, remember, in hydrochloric acid, and we've done some different things, but they react with metals such as zinc to produce a hydrogen gas. They change the color of litmus paper. I think I put up the blue one. I don't see what it is. Bases are known to have a bitter taste, and they have a very slippery feel, and they react with acids basically to neutralize their characteristic properties and to change the color from a litmus dye from red to blue. So that one doesn't work well, probably because of all the preservatives, and they've done some other stuff to it with the milk. So in 1880, the Swedish chemist whose name was Svante Arrhenius, developed the theory in which he defined an acid. And so his description of an acid you need to know for your quiz. Acid as a substance that produces hydrogen ions, or that H+, when dissolved in water. And it goes a little bit further about the concepts of what that hydrogen plus ion is. It could be an H+, and I might write that. You might want to go ahead and get this associated with an acid. Hold on, looking for a good marker. But I wrote this under an acid, so you would know what your hydrogen ions are. So if I look for an acid is going to be a substance that produces hydrogen ions, which could be H+. It could also be 3 molecules of hydrogen and 1 molecule of oxygen. Or it could be this thing that's called hydronium. So write that out. It describes this a little bit more on the next page. Hydronium. Yeah, that's an N and that's an I. hydronium, and that's what an acid dissolves to make these hydrogen ions when it's dissolved in water. So that, knowing these hydrogen ions is a quiz question, as well as you need to know how he described what an acid was, and that it produces hydrogen ions. The other thing you have to know is you need to know Arrhenius, that he is, that basically he is the one that came up with the concept that acids and bases applies only in aqueous solutions. So I'm going to say that again. So Arrhenius is the one that came up with the concept of acids and bases as applies to only in aqueous solutions. He also defined a base. You need to know this for a quiz question too. A base is a substance that produces hydroxide ions or OH ions when it's dissolved in water. For example, when hydrogen chloride gas is bubbled through water, it reacts with water to produce a hydrogen plus ion as follows. And they've given you a chemical equation so you can see what happens. They've also, this little example that they gave you with the litmus papers for knowing that acid turns a blue litmus paper into red is both a quiz question and a test question. Knowing that a base will turn a red litmus paper blue is a test question. So before we turn this page, I want to go over everything that we just did, because there's like a lot of questions right here on this first page. So first of all, know that acids have a sour taste. That's a quiz question. Know Savante Arrhenius. He's the one that came up with the concept of acids and bases as it applies only in aqueous solutions. He described an acid as a substance that produces hydrogen ions, and you have to recognize what those hydrogen ions are on the quiz. He also defined base as a substance that produces hydroxide ions, or OH negative, which dissolves in water. That is a quiz question, as well as your little thing that you've got down here at the base, at the bottom, that shows you the changes of litmus paper. So you need to know that acid turns a blue strip red on a quiz and a test question. You need to know that red turns blue in a base as a test question. So there's several questions right there on page 247. So let's go ahead and turn the page. And you're also going to have to know that first big bold word that's coming up, and that's the Arrhenius concept. So the Arrhenius concept of acids and bases is limited, and I tried to explain that a little bit on the previous page, is limited to aqueous solutions. So the Arrhenius concept of acids and bases is limited to aqueous solutions. And then, if you wanted to know where I got what these ions were, it's a little bit further down. Chemists usually assume the proton to exist as H plus and H2O, or written as H3O plus, which is also known as hydronium. So you need to be able to recognize this is what's happening in an acid. I think they give you some weird multiple choice question where they stick in something really weird. Remember, that's what's going to be associated with an acid, not something bizarre. So now let's go to the Bronsted-Lowry concept. So in 1923, a chemist named Johannes Bronsted and the English chemist named Thomas Lowry independently proposed an enlarged definition of acids and bases. It's like I'm looking up at the ceiling. Acids and bases that focused on the transfer or the exchange of a proton, or that hydrogen plus ion. So Bronsted and Lowry acid, you need to know that. So that's a bold word on page 248. That's a quiz question. The Bronsted-Lowry acid is a substance that can donate a proton to another substance. And then you have the Bronsted-Lowry base is a substance that can accept a proton. So let's talk about this. A Bronsted-Lowry acid can donate a proton. Here you go. Here's a proton. Where a Bronsted-Lowry base is a substance that will accept a proton. So the Bronsted-Lowry acid is going, hey, want a proton? The Bronsted-Lowry base is going, sure, I'll take that proton. That's how I get stuff in my brain. Sorry. It's like I drank acid or something. Since water is not mentioned in those definitions, they can be applied to many more situations than what Arrhenius alluded to earlier, such as in a non-aqueous substance or even in a gas. So that's why Bronsted-Lowry, they had to come up with these things in the late 1800s, early 20th century. So they've got hydrogen, they've given you a chemical equation with hydrogen chlorine, kind of showing you how these things are reacting and what they're coming up with. If you're really into it, you can read all that. Since we've got a limited amount of time on YouTube, I'm going to move on to your next quiz question. And your next quiz question is on page 248. If you'll turn over into the next column, don't turn it, go to this next column over here. So when a Bronsted-Lowry acid loses its proton, it forms something. That's what you have to know for a quiz. And it's that first bold word you have in the second column. It's a conjugate base. So when a Bronsted-Lowry acid loses its proton, it forms a the conjugate base. When a Bronsted-Lowry base gains a proton, it forms the conjugate acid. So, and they've given you a chemical equation again there at 15.4, showing you how ammonia reacts with water, and they show you what's the conjugate base and what's the conjugate pair. And you can look at that to get that better into your brain. Now, I want you to look at the bottom of the page, and this is on page 248, table 15.1. So you might want to highlight that, circle it, do whatever you need to make sure that this has a lot of test questions on it. And it's just simply how this base, what acid-base definitions compared to Arrhenius, compared to Bronsted-Lowry. So first, for an acid, you need to know that this is associated with an acid. So I've already said that a couple of times, but I'm just trying to reiterate it. Recognize that as associated with an acid. Go under to an acid to an Arrhenius concept. It's a substance that produces protons, or H+, in aqueous solution. That is a verbatim test question. Go ahead and circle that little thing. Go on over to the Bronsted-Lowry concept on that table. Substance that donates a proton. That's a test question. Go to base. Under the Arrhenius concept, it's a substance that produces a hydroxide ion. That's OH in aqueous solution. That's a test question. Make sure you know that. Go to the Bronsted-Lowry concept. It's a substance that accepts a proton. That's also a test question. So basically, for this test, you need to know that entire table and know how does Arrhenius, I want to put his name with his first name with his last name and make it Sir Virginius or something. But you need to know what Arrhenius's concept is for an acid base and what the Bronsted-Lowry concept is for an acid and a base. So make sure you highlight all that. Hopefully, of course, I'm assuming we're still going to be with an open book with this test, because we're not real sure what's happening yet with the world. So just make sure you get that highlighted in your book. So it's going to be easier for you to find this stuff, and it's not going to take you like 3 days to take your test open book. So let's move on over to page 249. So they're continuing to explain what happens when you combine ammonia with water, if you want to keep going through that and looking through all the examples. But where I'm going to end today is we're going to go through naming acids, and then that's when we get to polyproduct. I'll figure that out by tomorrow, how to say that. Let's go with naming acids, and then we are going to stop there. Tomorrow we'll start on page 250. So the names for acids differ from the names of the molecular compounds from which they form, since they differ in their properties. We shall look at two categories of acids, binary acids and oxyacids. So let's first of all look at binary acids. You have a table with some binary acids there. So you've got hydrogen fluoride, hydrogen chloride, hydrogen iodide, hydrogen selenide. You have all of those there. So binary acids are compounds of hydrogen and one other element, generally a non-metal, but sometimes a semi-metal. And the names of a binary acid consist of 4 parts. This 4 parts, and what we're going over, you need to know for a quiz. For example, the prefix hydro comes from the word hydrogen. Number 2, the stem or the root of the name comes from the non-metal in the acid. Then the suffix "ic", you add that to it, that's the 3rd thing. And then the 4th is the word acid. For example, you've got hydrobromic acid, right? So that's for example, a water solution of hydrogen and bromine, or bromine, however you want to say it, is hydrobromic acid. And in an aqueous solution, if you put hydrogen and sulfur together, it becomes hydrosulfuric acid. Table 15.2 lists other examples of a binary acid, and the root of the nonmetal name is shown in italics. So you kind of have to know how this is formed. They will give you the chemical equation, or just the, since I don't want to really say chemical equation because it's not like actually doing a reactant in a product, it's just the, what am I trying to say? Just the chemical letters for this, like HBr or H2S that we just looked at. It's going to give you just those, and then you have to come up with what is the name of that acid using those 4 things. That's on a quiz. It's also on a test. So let's go on down to oxyacids. Oxyacids sometimes are called ternary acids. They contain hydrogen, oxygen, and one other element. Aqueous solutions of these compounds are named based on the polyatomic ions produced when the acid molecules ionize in a solution. And for this reason, you might have to go all the way back to page 40 to kind of figure out what's happening with the names. That's the ionic compound table. And that can kind of just tell you, when do I use the suffix "ate"? When do I use the suffix "ic"? And those type things. And that's what it's going over on 1 and 2 and all the other things that you can read underneath there. So that is our chemistry lesson for the day. I'm going to have to go find an antacid because I just drank some vinegar, but it'll be all right. So let's go to the Lord in prayer. And tomorrow, April 14th, we will start here at on page 250. So Father, we just want to praise you and thank you for bringing us together again, and for just loving us and for just putting up with us, because as a people we can be pretty acidic sometimes. And Father, in this world that we've got going on today, we just pray that you'll grant the world leaders and our country's leaders wisdom, and that you'll just grant us wisdom too, as how we're supposed to act to our neighbors, but not just act to our neighbors, how we're supposed to show our neighbors Christ. We love you. In Jesus' name, amen. Have a good day, guys.